Yo, 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 what's up? Good morning, good morning. Yes, PG King, we're trying this out, combining the chats on stream. I've been wanting to do it for a while, and but I've been too afraid since it was against the Twitch TOS. But then I saw a clip with the Twitch CEO where they said that they wouldn't enforce that rule anymore. But last time I checked, it's still in the TOS, so let's see if he lied or not. But it feels great to have the chat on screen, so we're gonna see how it works. As for the game, yesterday we tried to get the blobs to be able to rotate by physics, which was way harder than I anticipated. But I think we have something now, because the problem was that the blob doesn't rotate as much as it needs to. And what it all comes down to is that, so we're pretty much trying to calculate, we're trying to do approximate, like we try to extrapolate how much torque force we need to apply in an impulse for the blob to rotate X degrees. But as it turns out, this approximation or this extrapolation, it's not that good when we're working with rigid bodies with more than 5 angular damping pretty much. So if we change this one to 5, we do get a very good rotation. The problem being, we still won't get a 180 degrees rotation, but I don't think that's something we want anyhow. So yeah. So what I think we're gonna do today is I'm wondering if, yeah, we're gonna improve this one a tiny bit. So we're gonna split it up like we did with the jump, I think. We're gonna see if we can make both the jump and rotation work in a good way. And we're gonna start with the rotation. First of all, I don't want the blob to jump this high if we're just gonna rotate a very tiny bit. So we're gonna add a jump force upwards minimum and a jump force upwards maximum, and then and then we're also going to add a minimum and maximum rotation and interpolate. So if we're only going to rotate 5 degrees, we're not going to jump nearly as high. If we're going to rotate 90 degrees, we're going to jump very high, or this much, I think. And all of this is also going to be controlled by some properties that we open up. Like, I want all of the blobs to behave differently depending on properties. So yeah, a lot to do. And one last thing. Oh, what was it? Oh yeah. We're gonna see if we can, or hopefully by the end of today's stream, we'll be able to test if we can like queue options. So a rotation action, or queue actions, I mean. A rotation action might take half a second or 1 second. So then we're gonna let it play out, and then when that's done, that's when we're gonna do the next action, and so on and so on. Yes. I'm not entirely sure just yet how we're gonna make this. Let's see here, what kind of actions do we have? Action. Didn't we have maybe terraform? Process, yes. Okay, so the idea is that what moves our blobs is currently a action. It's called action move rigid body, and it's a type walk. I think we're gonna simplify this and just make type movement, I think. Fuck, it's a hard question though. Yeah, I think we're just gonna make it like type movement initially, then maybe later on we might split it up. So that means that we're gonna split up the rotation part as well, but we'll see. So first of all, maybe we should do I don't know about these. Okay, we're gonna do not attack, but I want to have a movement. So that's how we're gonna do it. So the idea is this action is gonna be initialized. We can take a look at, let's do action terraform. Yeah, it's gonna be initialized, and I think, yeah, we're gonna add a dependency, which is Or maybe I want to take this in smaller steps. Let's see. Yeah, we're gonna wait a tiny bit. So, input handler main action event is gonna start. We're gonna set, this one is gonna set a focus point, and then it's gonna start the process, and the process will be first the blob will try and rotate towards the point, and then it will try and move towards the point. Yo, what's up, Antonino? Okay, let's start by cleaning up rotate constrained by time, and we're just gonna call this one rotate. Actually, towards. And then we're gonna have move towards. Okay. I don't think we need to normalize this one, do we? I'm just gonna make sure. God damn, Antonino. I'm sure it will go well. But I wish you good luck. Or maybe break a leg is the proper way to say it. I was pretty sure this one was already normalized, but whatever. Yo, what's up, Quincy? I'm good. How about you? Now we calculate T, now we calculate K, and then we calculate A. Okay. Quincy, nice to hear, nice to hear. have this one as well. I don't remember, do we want to have this one? We'll see, we'll find out. It depends on how you define new people, Antonino. Quincy have been here before. But like returning people, new people, it's all fun to me. It's very nice to know that some people actually want to watch this, you know? It's appreciated. Yeah, we're gonna worry about that one soon. Okay, let's see. They are a little bit compressed. Okay, let's clean this up. I wanna store... We're gonna have a lot of settings for rotation. Have I screwed up my... What? One sec. Okay. Here we go. We're gonna have a header here, and it's gonna be rotation setup. Beautiful. And let's see here. Rotation time. Okay, one thing first of all. We have angle in radians here. So what I want to do here is we're gonna call this one just angle, and then before we use it here we're gonna do math f degree to radians angle, and we're gonna remove it here because I want to work with, I like to work with degrees rather than radians. Let's use epsilon here instead, it's a little bit nicer. I want to use it here as well. Actually, I want to use it here and here and here. Okay. I agree, PG King, unless we're talking like, if it's strictly like what is it, 90 degrees, 180 degrees, 270 degrees, or 360, then I'm okay with radians. But other than that, no thanks. The reason I want to work with degrees here is because we're gonna pre-work it a bit. We are gonna add a few settings here. I think we're gonna do it like this. Public range, rotation range. We want to make this a serialized field. We can make it private as well. So this is how like smallest degree of rotation the blob can do, and the biggest rotation it can do in like one rotation iteration, if that makes sense. So for most blobs, the smallest one is probably going to be 0 degrees, and the biggest one will be around 80 degrees maybe. So if the blob wants to get to a point that is 180 degrees around, it will have to make it in 2 or 3 jumps, you know. And we're gonna add some randomization as well, because the blob might want to rotate 90 degrees, or let's say that it wants to rotate 40 degrees, but maybe it fails and rotates 45, and so on and so on. Which makes me wonder, move towards I think that the point here, D. I think we're gonna replace a distance we still want, but when we use it, the impulse here, we're gonna have to rework it a tiny bit, because I want the blob to always jump in the exact direction it's facing, right? So maybe we can simplify this one. We're gonna take a look later on. But okay, rotation range, and then we have range, rotation, rotation, rotation jump, should I call it? So this is the amount of force we're gonna push the blob upwards when we're making a jump, or it's gonna be multiplier actually. Rotation, let's do jump multiplier range. Okay, anything else? Before I forget it, I want to fix one thing in the graph, the generation graph. I want to change angular damping here. We're gonna go with between 4 and 5, I guess. Okay, good. Shouldn't we have... Okay, so when we do the rotation, we actually have a few other parameters, but it's angular damping, which is on the rigid body. We have mass, which is on the rigid body. And that's about it, I think. Okay, so let's use these real quick. So angle here. We're gonna do this. Rotation, let's see here. Angle is equal to rotation range lamp. And then down here before this one, we're also gonna add a, let's see here, float rotation jump force. It's equal to, so it's this one I want to replace. You know what? Yeah, we're gonna need to clamp this one. That's a little bit unfortunate. Let's see here. No, maybe it's okay. Okay, so the minimum angle is gonna be minus 90 and the maximum 90. Yeah, okay. Maybe we shouldn't have this one as a range then. I don't think so. I think we're gonna change this one to rotation max degrees. We're gonna make it into a float. Yo, what's up, Cooler SK? Depends on how you define science, I guess. So then we don't do a clamp, instead we do a... I guess we're gonna do a clamp, but it's gonna look a little bit differently. It's gonna look like if angle greater than angle max. Rotation max degrees. Then we need to do math F abs. Yes, that's what we want to do. Okay, let's see what... so rotation jump force here should be... math F inverse lerp between 0 max degree rotation max degrees and angle, but we want math F abs angle here. So this one is going to give us a value between 0 and 1. And that's what we want to lerp with. So this is wrong. So pretty much we check how much are we rotating between a 0 rotation and a max degree. Gives us a value between 0 and 1, and that's what we use to lerp in rotation jump multiplier range. But rotation jump force multiplier, and then we use this one here. Hopefully that will look sorta okay. Let's give this one some values initially. So rotation max degrees, we're gonna put this one at, fuck it, 90 degrees initially, and this one, new range, 0.5, 1.5. I think we're gonna go 2.0 here. Oh yeah, this is definitely science stuff. Goes right over my head. Something like this. Let's see what we get. So if we rotate a tiny bit, we don't jump that high. If we rotate the maximum amount of degrees, we jump a lot. So this is a very small jump, small rotation, and then we jump this. Yeah, that's pretty much what I want. Yeah, and then if we try to rotate more than 90 degrees, we fail. So we're gonna do it once. We're gonna check if we are within some degrees to the point we want to go to. If not, then we just rotate again. So maybe we can do that next, actually. Yeah, you know what? Let's take a look at rotation time 1 second. Feels a little bit overkill, maybe. However, it doesn't affect the end result that much, I don't think. Okay, we can try it one quick time. This is with 0.5. Oh, it actually gives us... Okay, this is good. So this is 0.5. Oh, is that so? One sec. System serializable. Do we need to make it action? Consume. System serializable should be enough. Why aren't we seeing it? We do add it, I think. Creature, animate entity, add action. Yes, we do. And here we have, okay, action handler. Ooh, okay. Dictionary. Okay. I would love to be able to debug this one. But one sec. Action handler, animate action handler, private action, animate actions. Let's do this then. Okay, here we have it. Action move, rigid body. And right now we have a rotation time of 0.5. Honestly, I have a hard time seeing any difference on rotation time. It's a little bit slower now, or nah, maybe not. So I think we're gonna yeah, rotation time is gonna be action move rigid body. Yeah, rotation time is gonna be or a full or maximum rotation, so that's going to be 90 degrees here. So we are gonna do we're gonna call this one rotation max time. 0.5. Let's do 1. Or yeah. And then we're gonna calculate rotation time. So I actually want to calculate, where do we have angle here? E angle. So here we're gonna do T angle is equal to, and then we just take this one. T angle. And then we're gonna do rotation max time multiplied with T angle. Yes. Although, yeah, I think rotation. Okay, this one I actually want to have as range. Rotation time range. 0.4 and 1 second. Rotation time range. Yes. This one doesn't affect it that much, but we're gonna use it to wait. So when we process here, we're gonna use this rotation time in some way, I think. Rotate towards is probably gonna return a float, and so is move towards. It's gonna be like the wait time. Maybe we can do... Yeah, I think we're gonna do it like this for now. Private point, yeah, target. Oh, action. We do have a target here already. Beautiful. On point change. What do we have? Action focus. Okay, just gonna do it like this for now. We're gonna do... Let's hide that one. And then we create a temporary private void set target. Base target. Not target actually, but whatever. Point is equal to point, and then we do start. Okay, so when main action handle happens, we set the target here, and then we start the action. We're gonna initialize it first, and then we're gonna start processing it. And as you see that it works, first of all. Okay, great. So now we have the process going at least. So we want to change, rotate towards, just going to return a float. Here we're just going to return 0, 0, 0, 0, and 0. But at the end here, we're gonna return... What did we call it? We don't even... We only have this one. So we're actually gonna do float rotation time. Yes. And we want to do the same with move towards, but I'm gonna wait with that one a little bit. Let's add a... I want a get angle to target. I'm wondering if this is a little bit over the top. I know, maybe not. get angle to target. And then we can replace... Oh, vector 3 up. No. Let's just take... Because we're gonna use this one to check if we're currently facing, like, are we looking roughly at the point we want to end up at? Oh, we don't have up here anymore. I guess that's not great. Then again, you know what? We're just gonna do this. Okay, so what I want to add here is rotation time range, rotation max degrees, rotation jump multiply range. And I also want to add error. So like I want to define, probably just going to do it as a float. I want to define a value or a degree that is like, if the error between the direction we're currently looking and the direction we want is less than this, then we don't rotate. So we're going to call it rotation angle error tolerance. At 5 degrees sounds good. Rotation angle error tolerance. I mean, yeah, sure. Yeah. But where I really want to use it is in process here. Because we are gonna do... You know what? Angle. Rotate towards, maybe. Mm-hmm. I think we're just gonna do, yeah, we're gonna do rotate. Just rotate. Like this, I think. I don't know if we want to do this here actually. So we're gonna clamp it first of all, and then we're gonna rotate. Because in the process, I want to do yeah, we're gonna go get angle to target, and then we're gonna do while. We can't really do a while here. We could, if it wasn't like a coroutine. Maybe a coroutine is the best way to solve it. Because like what we want to do is we want to instantiate a rotation, and then we pretty much want to wait until it's done, and then we want to check, are we facing the target now within an error? If not, rotate again. If we are, move towards. But that's not really how our current actions are implemented. Let's see how it was solved in action terraform. Yeah, we just do it like that. Initialize, okay. Doing it as a coroutine is hands down the best way. Oh yeah, but we're not working with mono behaviors here anymore. Okay. We can do it. What we could do is keep track of stuff like that on ourselves, like, so we have a float that is timer, and we have a float that is current time limit, pretty much. Maybe it's gonna be a little bit unoptimized, but we can. Yeah, let's see. Float, timer, and time limit. And then we do process. Here we do if timer plus equals to time dot delta time. And we do if timer is less than current time limit, return. Otherwise, we're going to do get angle to target. And then we're going to do current time limit is equal to rotate angle. Oh, no. We want to do get angle to target. And then we want to check if angle is less than rotation angle error tolerance. Or I want to do it the other way around. So we check if it's greater than then we do timer is equal to 0. Current time limit is equal to rotate angle, and then we start something new pretty much, and then we just call return. Right, that makes sense. So timer, add to the timer if timer is less than current time limit, return. Otherwise, we get the angle to the target, and we check if we need to rotate. If we do, we set the timer to 0 and the current time limit, and then we instantiate the rotation, and then we return. If the angle is less than this, then I guess we want to have a get angle to target. Then we also want to have a get or private float get distance to target. That's probably the way we're gonna do it. I just want to see it. Okay, timer, good. We can probably reuse this one soon. But let's see. So we have rotation set up, movement set up. This one is old, so And then we want to have something similar to this. That's going to be the first. So we're going to have movement angle error. We're going to have distance error tolerance, and it's going to be 10 centimeters maybe. And let's start with that. So if this is okay, then we're gonna do float get distance to target. If distance is greater than distance tolerance, error tolerance, then we're gonna do timer 0, move towards, but we're gonna wait with this because this one doesn't return anything just yet. I think this is how we want to do it. But the main thing is that if we get to this point, we want to set state finishing, I think it is. Action, assume, process, set state finishing. Okay, let's see if we can get a double rotation then. So if we want to rotate more than 90 degrees, we're gonna make it in, or do it in 2 jumps. Index was out of range. It's not a good start. Let's see what's happening here. Okay, active actions are probably 0 then, I suppose. But what the hell? So we shouldn't need to do this, alright? I'm wondering if... So we're adding this action in a little bit of a weird way, actually. Wonder, do we call instantiate? We're instantiating it as well. Try this instead. What? We do have a few actions already added here. How is it possible? Active actions. Ooh. No. Action list, actions, then we add this one, action type movement. We add a listener here. I want to know what index we're trying to fetch. And also the fact that it works once without errors. Then, okay, we get it after the fact, okay. One, 0. So that's when we try to get index 0. So when it's done, the only reason I can think of is that we're doing this. So we're calling update, we're doing this, then we set state finishing. By setting state finishing, this one is going to be notified. And this should happen. But that should be after this. But could it... Hey, what's up, Yash? You pretty much don't capture the creatures in this game. You're more like attracting them to come live in your garden. And if it's nice enough, they want to move in. And then, of course, I have one concept I'm thinking of, like that the player can actually go out in the wild and like capture the creatures, but that's far into the future. That's not going to be in the initial game. Did I say you attraction them? I think I said you attract them. Ah, fuck it. So like if you change your garden in a specific way, you might get a certain type of creature that comes and visit your garden. And hopefully you can learn enough about the creature that you know how you will have to change your garden for that creature to move in permanently. Should we just call it taming? I don't know, so like you could... I want to have a, like... The player character doesn't necessarily need to be active in the process, if you know what I mean. So in this very simple example, we can have like a creature that likes apples. So if you plant an apple tree and then you just run away and do other stuff, and then when you come back to your garden, you might find that a couple of creatures have moved in, you know. So it's not taming per se. And that's a good question, Yash. Initially, no. Like, if you have built your garden in a certain way that it attracts a certain creature, they will come and move in. But it's a good idea. Like, maybe buy some spray or something. So I guess you can't refuse them, but you can, in the future, you will probably be able to the opposite of attract them, if you know what I mean. So worst case scenario, they definitely invade. Okay, back to this extremely weird issue. We're gonna do I wanna do active actions. Let's see what we get by doing this. Yeah, I was pretty close to saying unattract them, but yeah, maybe that's a correct term. I don't know. Okay, where do we have the error? Yeah, we just have one action in the list. We're iterating twice. How does this make sense? And yeah, as for the combat part, we're not gonna. They are not gonna fight, but they are going to like race and stuff like that. Race each other, that is. I'm wondering, let's see here, active actions. I'm gonna do this. Let's see here. So like there are no bad creatures in the world. It depends on how you define bad creatures. We're definitely gonna have eventually creatures that like to consume other creatures. So I guess in some ways it's going to be like more akin to real life nature as opposed to Pokemon. Active actions list is empty. But we do get 2 entries. Are we adding it twice? Active actions. Focus, inspect, consume, action, move, rigid body. Okay, that explains it. Why is it being added twice? That's stupid. Okay, so we're doing this in a pretty hacky way when we are instantiating it and adding it like this. Yash, I need, like, I like working on things that are pretty. It keeps me motivated, you know? It's also nice to like switch it up, you know. So you work hard on some mechanics for a while, and then you do some visuals, like switch it up. Action handler, add action can perform, add. Yo, what the fuck? Yeah, okay, this is weird, but I see. I think we're adding this one twice. Oh, actually, no, we're not. But we do this twice, I think. Yeah, we are. Okay, that's not good. We do this after. So add action. Okay, this depends on if we have instantiator or not. I think we're gonna make it action list. We're just gonna do it like this. Yash, this is fuck, I don't even know what's it like. I have a GitHub subscription, so it's Copilot, I guess. But the specific model that is used it's up to you or up to me. And currently I'm just on auto to burn through my tokens a little bit slower, if you know what I mean. But I guess like VS Code is like an AI editor first now, so this is just all built in. Yeah, I think this is everything we need to do. Adding actions at runtime to our action handler state machine is something new. That's why we're seeing a little bit of problems like this. Because the idea eventually is that get out of here, is that it's going to be added on spawn, so to speak. So we're gonna add it in our graph. Okay, no, we don't get an error, but it's also processing forever. Or, you know, maybe it's not. Active actions. We don't have any active actions. There we go. Oh, okay, I screwed up. I know what we've done. So we can only rotate in one direction, but that's good. And if we jump very tiny bit, we're not going to put it in an active action. Okay, that's good. Oh, let's see if we can make it jump twice. 1, 2. It's a little bit long between the jumps, I guess, but 1, 2. Oh, nice. What's up, Tamashi? What is your computer spec to do this project? Currently, I'm just sitting on a 1080. And the CPU, I don't even know. So we're running some ancient stuff here. So the thing I screwed up is we want to do math abs here. Yeah, wow, indeed. Okay, that's good. I'm also wondering... Let's keep this rotation range. Okay, so let's see if we can rotate it and then make it move. But I want to alter the move towards point a little bit, or the... I guess it's move towards. Let's see here. Yeah, I think we're gonna change this one. So we're gonna have move, and float. And move here is gonna be float, distance. Move type. Yeah, we want to change this. We want to do something like this, rotation time range. So we're going to do rotation max degrees. We're going to have movement max distance. One meter maybe. And then we're gonna have movement time range. And we're gonna do something similar. 1 second to move 1 meter. That's a bit too much, maybe. I don't know what we went with. Move time 0. Maybe not. Movement time range. And maybe this is enough. So what we're gonna do here is distance is equal to math min distance movement max distance. And then we do float t distance. And in move time including air time, we're just going to call this one move time. And it's going to be equal to... Yes. And now I don't want to multiply with this one anymore. And calculate movement velocity needed point. That's just a direction. It's actually distance as well. If I recall correctly, we had some issues with thresholding it here. Or maybe we didn't. Let's see. Maybe we didn't. Let's try and skip this. Let's threshold it over here. So the only thing we want to send in here then is float distance and float time. Okay. Yeah, we change to distance here. One sec, angle. Let's say target instead. Distance move time. So D here, D. I wanna do point position. Yeah, I think we're gonna do this. So distance multiplied with rb.transform.forward. And then we calculate this. We don't limit it here. Yeah, let's try this. And now when we have this in added, we can also remove this one. One sec. We're also gonna do calculate movement velocity needed. Move. This one is gonna return a float. And it's going to be return move time. I think it's a bit too actually, instead of... We're also going to listen on grounded down here. So even though we're up in the air, even though we're past the time limit, if we're still up in the air, we won't be able to do this. Current time limit move. Okay, I think I like how this is structured. Actually. Okay, so now we should be able to click anywhere and the blob should first rotate one or more times and then it should jump one or more times. We can try with something simple initially. Yes, okay, I know what's happening, I think. Interesting. Okay, so yeah. Did I forget to check against get distance? If distance error tolerance. It's like it never finishes. But I think that's because, yeah, when we have moved to the point, we rotate towards the point again and then we over jump. But why are we jumping? Distance error tolerance is... If we do 1, we shouldn't jump, right? Yeah, then we stop. Huh. So we jump a little bit too far. So if the distance is very small. In fact, this is a less than 0.5, isn't it? Let's see. 0.5. That's quite a big distance. 1, 2, 3. And then it jumps a bit too much, rotates back, and then it jumps too much. But now it should be... Okay. Yeah, the center of the point is within the blob, so I guess 0.5 is actually... Okay, I see. 0.5 is quite a small distance error because we're not measuring from the ground, we're measuring from the blob center. Okay, but what I see here is that, so yeah. Okay, that's something we need to change, I think. We want to measure from the bottom of the blob, for sure. But apart from that, I love this. So if we click here. Wow, and then it's going to be so easy to give it some agency by just making it search for food or whatever. Maybe we have a little bit too much of an up force and too small of a forward force. Wondering about the pause as well. It's like it jumps, and pauses, because then it can get it in one shot. Movements, time, range. Yeah, I see. So I think it jumps as far as it can. Okay. I'm still wondering about the... see how it looks with... let's randomize the blob visuals. So let's go with a -1 seed, I think. No. Actually, if we just leave this one empty, it should randomize the seed. This one is quite a lot slower, isn't it? I wonder if that's purely because of the mass difference. Way too firm. I want to see if we can get a very jelly-like blob, like extremely jelly-like. Well, that's... Wow. Sometimes we can see that the blobs wait a bit before the next jump. I wonder what that is about. Is that like a small... Yeah, maybe. Yo, that's probably because they are rotating, I think. Does that make sense? So we have a small radius, or we have a small degree of error, but as we move closer and closer, that degree is going to become greater and greater. Yeah, that's probably it, actually. But I definitely want to make it jump more forward and not this much upwards. I guess that is going to be one of the things we can add as a property. We're also going to add some extra forces to the soft body when we jump, but I thought we would be getting more for free here. I wonder if these are 2, if we make them to 5. Okay, that looks too weird. What the fuck? Or if we make them less strong, I guess. 200. Yeah, the eyes as well then. Okay, not the eyes, I guess. Yeah, we can play around with this quite a lot. Ooh, this one looks pretty nice. It's way too firm. Maybe we wanted to wait a little bit between jumps. We can do this. I just want to see if I can make the effect of the jelliness a little bit more apparent without, like I said, we are gonna add forces to these joints when we jump and stuff like that, so we're gonna first squish the blob downwards and then jump, you know, and then we're gonna elongate it a tiny bit when it's in the air, so things like that. So if we have external forces like something else touching the blob, then the joints are pretty much gonna make or do all the work for us. I was hoping that they would be doing a little bit more than they are currently doing with the jump, elongating wise, but we can also make it like so it's going to be very similar, like a procedural animations of sorts. But what I want to add is movement time range, and then we're going to add a serialized field, private float, extra movement. We're probably gonna have this later on, so we might as well now. Free time. And then serialized field. Movement post. Right. And let's do 0.5f for now. So when we do a move here, return move time, we're going to return movement post time. I don't care about pre right now. So now we're hopefully going to see a jump, and then it's going to wait a tiny bit, and then it's going to jump again. And maybe we are able to see a little bit more squish here on landing. Ooh, that's a weird one. A tiny bit, I suppose. You know what? Something I want to have during debugging here is I want to have the seed available. Because this blob looks pretty cool and behaves pretty cool. But I have no idea which seed that generated this blob. Let's see. Random value. Yeah, let's replace this one with init state seed int. Can we get if you seed wish we could get it in its state. Let's see. Unity random. Fuck. I was hoping that this one. Okay, I guess we can't fetch it, but we could work around it a bit by randomizing our seed here. I wonder how weird that would be. Yeah. Yeah, one sec, be right back real quick. Okay, back. Sorry about that. So, like, if we get a nice looking blob, I definitely want to be able to recreate it by using a seed like this. So, I think we're gonna do a little bit of a hack here. Although I wonder if that might screw it up if yeah, we're gonna do it like this. Where are we? Yeah, if we use this state to generate a random number, and then we set that number as the seed, and then eventually we revert, that means that if in the unlikelihood we get two or we spawn two blobs at the same time, they are gonna be, and we're spawning them without seeds, then they're gonna be the same blob pretty much. Probably want to avoid that. Guess. No. Okay, so if we randomize the seed. Yeah. So if we do it like this. Use seed is always going to be true. So we do. If this one fails. If this one fails, we do seed int is equal to random dot Okay, I guess we can just do, seed int is equal to random.value multiplied with int.max value. Now we do int. So we try and get seed from the creature definition. If we can't get it, then we randomize a seed like this. And then, after we have done this, that's when we save the state and revert it. So even though we instantiate two blobs at the same time, or in the same frame or whatever, they are not going to be the same blob. Beautiful. And then we do this. We don't need to store if. And then we'll revert the state here. And instead of a random value at the end here, we are gonna do seed int. So the blobs will be named, the ID string of the blob, the time it was generated, and seed at the end. Okay, great. I just want to try this real quick so it works, because if I see a very nice looking blob, I want to store that seed number. Although as soon as we change the graph generation for the blob, we're gonna get new blobs, but whatever. Okay, this might not be a... This is a pretty bad blob. But what do we have? Oh, what the fuck, that's a long... Let me just write it down real quick. Yeah, that's a little bit laggy, but okay, let's see if we can generate this blob again. By doing creature blob definition seed. I think that's the same one. Okay, good. Okay, so what about the when we have arrived at a point and it gets stuck in its infinite loop? How do we want to solve this? Like, it's definitely jumping too far. If we just change the movement time range, if we just minimize this one quite a lot, then we will get a very small jump, right? Do we need to minimize it even more? 5? Yeah, 10 centimeters. 0.5. Kind of radius do we have on this one? Maybe it is 0.5 actually. Okay, yeah, this is the point we're measuring against. Maybe we just want to measure the distance in the XZ plane. That's one solution, but that's gonna make it harder to work with jumping up on a hill. We could also measure the point distance to the capsule collider in the middle. That's one way to do it, I guess. The capsule collider actually destroys a bit more than it helps, I think. How does it look if we movement movement max distance 1? Let's go 4. Okay, that's a little bit better, I guess. It's all a relationship between... Okay. So it's a relationship between time and distance. So if we want the arc to be a little bit more forward and less upward. So the height of the arc is decided by the relationship between time and force. Okay, this is pretty fucking cool. Let's remove the distance error tolerance 0.8. Yeah, what's up, bot? Hell yeah, we're gonna do that eventually. I think that will make it look way better. We already have some movement pre-time here, which is gonna be for the procedural animations. Okay, so this is how it looks. I'm also thinking... So right now the rotation of the blob is purely based on the direction to the point. We're probably gonna let the brain of the blob handle that. So for instance, if... Okay, now I'm just thinking aloud for future when we want to add agency to this blob. So like, let's say that it's getting hungry, so it's gonna start searching for consumables in the vicinity. And if it find a consumable, like, I don't think we want, let's say that this gray thing is the consumable. I'm not, yeah, maybe for the blob though, but I wonder if like we want to stop short. So we're gonna stop a little bit, or the point it's gonna jump to is actually gonna be located like in front of the consumable. That will probably work. The landing looks pretty good, even without any additional animations. But yeah, we probably want to squish it before and elongate it during the jump eventually. Yes, we can do something simple today. I only have like 20 more minutes today, but I wonder if we can get something working real quick. What we do need to do is... So the blob currently consists of... What is it? 8, 10 bones. At instantiation, we need to cache these would be nice, but I mean, we can probably do something. Okay, let's do something real quick. So we have a blob and it has a soft body handler, which has it doesn't know anything. Okay, so when we create the soft body, we definitely want to create a... we want to have a list of the soft body bones here. And then we can create a quick method here, which is like apply force to top bones. So before we're gonna jump, we're gonna apply a force downwards. And then we'll check. Let's implement something real quick. Hmm. I want to keep track of this one, I think. Then we want anchor rigid body, and we want, yeah, we want the rigid bodies. So or we can just do bones. I wonder if we want to do this. Pen. Why don't we have... Or yeah, we can append it like that. But don't we have a this.bones dot add range bones? Let's see, let's rename this one additional bones. Soft body handler, and here we want to do soft. I guess we can do set parent soft body handler dot add or set anchor rigid body soft body. Oops. Here. And then let's do it in the like this. And then we also do how we create the bones here. So yeah, maybe we can wait a bit with this. And yeah, I think we're gonna take this one and put it down here. And then we'll do soft body handler And add bones. Okay, yeah, that's true. Here we have bones, but yeah. Bone, 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 bone. Yes, we need to do game object, get component. Yeah. Possible optimization. But okay, this means that we should have some nice references here to work with. And then we can try and do... So what I want to do here is something like this. Public void add force. 53 force. And the idea is that we're gonna loop through the bones. We're gonna check their direction to the anchor, rigid body, and stuff like that. We're gonna So for instance, if we're talking about the squishing or squash on the blob before the jump, then we're gonna send in a force that is pointing downwards. So we're gonna loop through each of these rigid body bones and we're gonna get their direction toward the anchor. And if the dot product between the force we want to apply and the vector to the anchor is within some threshold, then that bone is going to be included. But yeah, that's we're gonna start with something simple. So maybe we can just do for each add force, and we want to do it as force mode impulse, I think. But that's probably gonna look a little bit weird. We can see. Yeah, we don't have a reference to the soft body handler here. We're gonna have a reference to it in body definition eventually. But right now we don't, so soft body handler. And the problem now is... Yeah, exactly. We don't want to add it here. We want to add it and then wait a little bit and then... So I guess we're gonna have to send in a timer here, I think. Or we could hack it like this. Let's just cheat it a little bit. So private pool. Not done, then we want to do one is a little bit too much. It's 1.0. I wonder how this would look. Let's add 2 maybe. Does this make sense? If it's not done and at the distance, then we set timer and current time limit, and then we add this force and free jump done is equal to true. And then later on we're not going to do this, but instead we do this. Let's try it. It's just a quick implementation to see if it sorta looks and does what we hope it will look like and do. Of course. We need to instantiate this one as well. Oh, we actually got a very quick... Yeah, we do. That's actually way better than I anticipated for this first iteration of it. Although I wonder. The force impulse doesn't really work that well with such strong springs. So we might have to look into another way of adding it, but oh well, that's a first step. But I'm gonna have to run now. Great progress today, I think. Hopefully we can begin with the agency, the brain, in the beginning of next week. So thank you so much for watching. But ideally apply force over a small interval downward with a bit of the opposite direction to the jump direction. Yeah. That's a good point. We're hopefully gonna continue experimenting with it next week, and hopefully it will look amazing. YouTube bot and everybody else, thank you so much for watching. Have a great rest of the week and weekend. And hopefully I'll see you Monday. Peace.